In this video, we are going to see what a polynomial function and rational functions are. A polynomial function are of different type. The constant function y equal to a is of degree 0. The linear function y equal to ax plus b is of degree 1. The quadratic function ax squared plus bx plus c is of degree 2. And the general equation y equals a n x to the n plus etc. a naught, which is of degree n, is also a polynomial and is of degree n. We can call a polynomial of degree odd degree when n is odd, and the polynomial becomes an even degree if n is even. Let's take this function f of x equal to x squared minus 36 x cubed plus 27 whole cube, and let us try to find the degree of this function and the x-intercept and the y-intercept. The degree is obtained by the highest power of x. The highest power, when we expand, we get for the first factor x squared is the highest power. The second factor, it will be x cubed whole cubed. So when we simplify, we get x raised to 11. So the degree of this function will be 11. In order to find the intercept, x-intercept, let us enter this in our graphing calculator and graph it. And if we are interested in finding the x-intercept or the y-intercept, we can find the values of the x-intercept and y-intercept by taking the table. In our table, the x value is negative 6 for y equal to 0, and y value, when y value is 0, we have another x as negative 3, y is 0 when x is 6, and those 3 points are the x-intercept. We can also find the x-intercept as well as the y-intercept using the value option of the graphing calculator and the 0 option. So if we are taking the 0 of this function, then again we can find x as negative 6, x as negative 3, and x equal to 6, and where those 3 becomes the x-intercept of this function. Now to find the y-intercept, we can make use of the value, that is, find the value when x is equal to 0. So that value becomes our y-intercept, or from the table also we can find the y-intercept, that is, we are trying to find the value of y when x is equal to 0. So in this way we can find the x-intercept, y-intercept, and the degree of a function. We can also graph the functions using a graphing calculator, and we can check whether it is continuous or not continuous. In the first case, when we take the function f of x equal to 2 absolute value of x by x, and when we graph it, it looks like the function is not continuous. There is a discontinuity at the point x equal to 0. For the second function, though it is continuous, it is not smooth because there is a sharp corner at the point 0, negative 3. Whereas the last function x squared, the quadratic function, x squared minus 4x plus 5, is a very smooth continuous curve. The rational functions are functions which are obtained by dividing one polynomial by the other. That is, it is the quotient of two polynomials, say n of x and d of x. Both n of x and d of x are polynomials, and the denominator is not equal to 0. In order to find the domain of this polynomial, we take all the cases, all the real numbers where the denominator is not equal to 0. So the domain of the whole set is such that it has all real numbers as the domain for which the denominator is not equal to 0. So in our first function f of x equal to x minus 3 by x minus 2, the domain will be all x variables except the case when the denominator is 0. The denominator is 0 when x is equal to 2. So except at the point x equal to 2, the function is defined. We can also talk about an asymptote for a function. Asymptotes are the lines which meets a curve at infinity. So it almost touches the curve, but it never touches, it touches only at infinity. So if in this case, in the first case, at the point x equal to 2, when we draw a vertical line, the vertical line through x equal to 2 does not meet the vertical line at x equal to 2 does not meet the curve. So we can say that the line x equal to 2 is a vertical asymptote. The same way, when we draw the line y equal to 1, that again doesn't meet the two curves, so that was a horizontal asymptote. For this curve, second curve, both the lines x equal to positive 2 and x equal to negative 2 are vertical asymptotes. And the x coordinate, sorry, the x-axis, which is y equal to 0, becomes the horizontal asymptote. For the third equation here, x plus 1 by x, we don't have any vertical asymptote or horizontal asymptote. It doesn't have any vertical asymptote. It doesn't have a horizontal asymptote. We can find the cubic regression just like the way we found the linear regression. We can also find the cubic regression. Let's make use of this data given here. Here, x represents the number of years from 1960. That is, we have to take 1960 as 0. And so 1970 becomes 10, 20, 30, 40, and 50. So for these, we have the different two cases, marriages and divorces. We are trying to find the cubic regression for the marriage rate. So let us take the first two columns and enter that in a graphing calculator. Since it starts from the initial point, we take L1 as 0, 10, 20, 30, 40, 50, and the marriage values are given. So that is taken under L1 and L2. And use your stat plot to select the scatter plot as we did in linear regression. We can graph the plot. We can just get the scatter plot. The points are all scattered all over. So if we want to get a cubic equation for this, take stat calc under that, search for cubic regression. So in your graphing calculator, when you select your stat calc, the cubic regression is number 6. So if you press number 6, you check whether it is under L1 and L2. This is the type of key you have to input in your TI-84CE. If it is just TI-83, maybe you can just enter the value under L1 and L2. Make use of the stat calc number 6 and calculate. When you calculate that, you will get the cubic equation ax cubed plus bx squared plus cx plus d, where the coefficients a, b, c, d are obtained. Substituting this value in your equation y equal to in your graphing calculator and graph it, you'll get the cubic regression for the given function. So the cubic regression functions can also be used to predict the values which are outside or inside the region. So you can extrapolate or interpolate the values. Let us take this question where y is equal to 2 to the x. Let us try to graph this function. So if we want to graph, we can make use of a graphing calculator. And since in all these choices, the window is from negative 5, x ranges from negative 5 to positive 5, y ranges from 0 to 25. So if we take the function y is equal to 2 raised to x in a graphing calculator and adjust your window. X minimum is -5, maximum is 5 with a scale of 1. Y minimum is 0, maximum is 25 with a scale of 5 because that's what is given in the diagram. And when we graph it, we get the graph like this. So comparing this with the given result, we know that the answer is going to be B. So in this video, we talked about the regression equations and the polynomial functions. Thank you for listening and thank you for watching.